Good afternoon. Today I'm submitting this video quite a bit late, but that's okay. That's the purpose of this channel, is just letting my mistakes be mistakes and falling forward. So thank you for joining me today as we fall forward. We're in the middle of a storm, or should I say a storm cloud, because there's really not too much going on at the moment all around the edges of the cloud. But we've had a lot of thunder out here. And what I want to tell you about today is thunder. Think about the last time that you heard thunder. Did it all arrive as one big snap, where in one moment you heard it and then in the next moment it was gone? Like, is that how you heard thunder? Or did you hear thunder like a big rumble that vibrated and maybe shook and continued over the span of a couple of seconds? So why does thunder arrive in a rumbly fashion? Why does it sound like it's vibrating, shaking, and rumbling? The reason is, well, you didn't think I'd let you off that easy, did you? Think about thunder and think about lightning in particular. If a lightning bolt were to start up here in the clouds and travel all the way down to the floor. What is lightning, first of all? All right, we need to start back at the root. What is lightning? Why is it so bright? What makes lightning so bright? Yeah, electricity, right? And if electricity is going through the atmosphere, so much electricity traveling all the way through the clouds, all the way through the sky, all the way to the ground, maybe, 30,000 feet of a bolt of electricity traveling. What do you think is going to happen when that much electricity gets transferred in an instant? What do you think the byproduct, besides light, what else do you think is going to happen when all of that energy gets dispersed through one lightning bolt in an instant? Exactly, you're gonna get a buttload of heat. So the heat that is created from a lightning bolt is how many times hotter than the sun? 5 times hotter. So if you saw a lightning bolt travel down the sky, or the next time you see it, just know that you're looking, basically, at least in the perspective of heat, you're looking at a sun. Now, obviously, a sun is not electricity. A sun is fusion of helium combining into, hydrogen forming helium, and then forming larger and larger elements. But that's to say that a lightning bolt is an incredibly hot experience of electricity. And when that happens, in that split second, imagine my finger were a lightning bolt. The air inside my finger would be so unbelievably hot in such a fraction of a second that it would expand violently. So violently, in fact, that it would push on all of the air around it. Because it's essentially air that is exploding from being so hot. It's expanding so explosively that it pushes against all of the air around it, making sound waves. So the lightning bolt goes, and at every single spot along the lightning bolt all the way from the sky down to the ground. At every single spot along the bolt, you have it pushing against the air around it, making sound waves. So there's sound waves being made up here, sound waves being made here, sound waves here, and sound waves here at every spot. So it's not like you have a lightning bolt sending just one signal boop, to the listener. You have a lightning bolt making infinite amounts of sound waves from if this imagine this is my finger. That lightning creates infinite amounts of sound waves that can do some weird things in the atmosphere, like stretch and get faster. And depending on how the atmosphere looks, you might get several sound waves hitting that person, and some sound waves that go off in different directions. But think about that for a moment. Some sound waves get there first, like this one. Some get there second. Some get there third. So you're gonna hear boom, 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 boom. And if you hear that, if you get millions and countless, also hi Patita, have a good day. If you have countless sound waves hitting your ears at the same within a couple of seconds, you're gonna not just hear one big, but you're gonna hear a, you're gonna hear a rumble of sounds. So that's to explain why lightning is not just one big snap. It's kind of like you're hearing an infinite amount of lightning bolts, because a lightning bolt creates sound, but independent sound waves all along its body. It's pretty cool. All right, last thing to mention real quick. If an atmosphere is colder on the ground and hotter up above, do you think sound is going to travel faster in the cold air or in the hot air? Hopefully you said the hot air, because hot air is able to move more. Think about a cold air being so cold that it was like an ice cube. How much is an ice cube going to be able to move? Not much, right? An ice cube is stuck, it's solid, So at the extremes, cold is not moving much. Hot things are moving a lot. And so sound is able to move a lot of particles up in, or wherever the warm air is. So if you're in summer, maybe like right now, we got a lot of hot air down here on the floor, and then up in the atmosphere, do you think it's hot or cold? It's probably really cold up there, right? And so you got hot air down here, cold air up here. The sound is gonna rumble along the floor and then reflect upwards. I can't go into explaining why at this moment. Oh, actually, yeah, I actually don't understand why. Because the sound waves that are made up here will stay within the cold. They'll either dissipate, or they'll kind of curve up, or they'll curve towards the or they won't go as far because they're in cold air. And then the hot sound waves will go fast and far. But if you're in the winter and you got cold air down below, in the winter the air is probably pretty warm comparatively up top because of how cold it is on the floor. So you got cold down here and hot air up here. If you have a lightning bolt that goes all the way to the floor, the sound from the floor is gonna go nice and slow through the cold air and eventually hit the person. And the sound waves that go up into the hot air are gonna travel so fast that they're gonna actually kind of curve back down around. And And because of the fact that it's cold down here and hot up here, the gradient is going to pull them back into the cold and hit the person again. So sound that was meant to go up here might be boomeranged back down to the person, which means the person hears both the cold sound waves and the warm into cold sound waves. Therefore, they hear much more sound than they would have, making lightning sound louder in the winter. Wow. All right, we're learning a lot of things today. Thanks for watching. Hope you guys have a good day. See ya. And here are the parents, just in time to learn about lightning. Woohoo!